Good evening. We're going to do Chapter 6, Section 5, which is on inequalities. A quick review of how to graph these. The two that you're looking at only have one letter. So when it has one letter, you graph on a number line. So x is greater than negative 5. That means we're going to go to negative 5 and put an open circle. And then since it's greater than, we're going to shade in all of the greater than numbers. The open circle is because there's not the equal to. If there was, we would have filled the circle in. So if you look at the next one here, just one letter, y is less than 0 or equal to. So at 0, we're going to put a closed circle. And then we're going to go to the less than or equal to side. Alright, so instead of just one letter, we're now going to have something in y equals mx plus b. So the first question is, which coordinates are solutions to this inequality? Well, you can do this one of two ways. You can plug the 4 in for x and the 8 in for y and test it. I guess that's probably the easiest for now. So is 4 plus 5 greater than 8? And the answer is yes. So that's a solution. Is negative 3 plus 5 greater than 0? Yes. So that's a solution. Is 5 plus 5 greater than 9.5? Yes. So that's a solution. And then negative 4 plus 5, is that greater than 3? So for all of these, I'm plugging this in for the x, this in for the y, and checking to see if that inequality is true. So 3 is not less than 1, so that is not a solution. So an easier way than testing everything like we just did is to actually graph things on a coordinate axis. Now, this is a little bit weird because there's no x, but remember if we're graphing the equation y equals 5, what that looks like. If you think about a table for y equals 5, y always equals 5 no matter what x is. So I can plot over 0, up 5, over 1, up 5, over 2, up 5. So y equals 5 is the horizontal line at 5. Now there's no equal to here. It's just greater than. So instead of a solid line, I'm making a dotted line, and then it's greater than, so I'm shading above towards the greater than numbers. So everything in my shaded region is a solution. The things on my line are not a solution because it's dotted, and then the things down here are definitely not solutions. So then we're going to try the x. Now think about x equals 5. If you think about that table, x is always equal to 5. And y can be anything. So over 5 up 0, over 5 up 1, over 5 up 2, over 5 up 3. This time I do have the equal to underneath. So it's a solid line connecting those dots. And then it's x is less than, so I'm shading to the left. So everything on my line and everything in the shading are solutions to that inequality. So now we're going to graph a full equation and figure out all of the ordered pairs that are solutions. So I'm still thinking of y equals 2x minus 3. And if it's not in y equals form, like if the y is not alone on the left, you need to get it there. So if I thought about some ordered pairs that make this work, 0 would give me negative 3. It's the easiest place to start. Then I have a slope of 2. So as x goes up by 1, y is going up by 2. So that means 2 would give me 1, and 3 would give me 3. And you could plug that in and test, or you can just know that the slope is 2, so you're increasing by 2. So we're going to plot these points. 0 gives negative 3, 1 gives negative 1, 2 gives 1, and 3 gives 3. And then I do have a solid line because of that equals to. So that's my straight line. And then it says y is greater than. So I'm shading above. I'm shading to the sky, to the numbers that are bigger. So everything above this works, and everything on the line works. And everything down here does not work. So if you want to pick just a random ordered pair, like 0, 5, you could plug that in and it will work. If you want to, 5 is greater than or equal to 2 times 0 minus 3. Yes, that works, because everything in that black region works. So you could list multiple points that work. Okay, we did all that. Alright, so now we're going to do these two. So again, the first step is to, I always think about it as the basic equation. And if it's not in y equals form, you need to get it in y equals form. And it's way easier if y is on the left, because then you read the inequality as is. Okay, so my table. 0 gives me 4. Now I'm going down by 5. So 1 is negative 1. 2 is negative 6. 3, if you know it's a line, you only need 2 points, but we'll keep going. All right, so 0 gives 4. 1 gives negative 1. 2 gives negative 6. And the other one's not going to fit. And again, you can even look at your slope, because you're going down 5 over 1, if you want to keep doing that also. All right, so we're going to connect. Whoa. Hold on here. Let me connect my dot better than that. Or I'll attempt to. Oh my gosh. Okay, that's supposed to be a straight line. I wonder if I can undo that. I don't know how. Okay, we're just going to pretend that's a straight line. So hard to do on the board. Okay, that's a better straight line, I think. It's just giving you time to perfect your graph. Okay, there's my perfectly straight line. And it is solid, thank goodness, because of this line underneath there that reads or equal to. And then it's y is less than, so we're shading below. So everything in the shaded region below is a solution. All right, over here, we have 3x plus 1. So that means at 0, you get 1. And then as x is going up by 1, y is going up by 3. So 1 will give you 4, and 2 will give you 7. Again, we have a solid line because of that equals to. So 0 gives 1, 1 gives 4, and 2 gives 7. All right. Solid line because of the equals to. That should go through all 3 points beautifully. Okay. And then it's greater than, so we're shading above to the sky, towards the bigger than numbers. So everything in the red region and on the line will work. So we're going to do a story problem. Ada has at most 285 beads to make jewelry. So at most 285. So something has to be less than or equal to 285. And then it says a necklace requires 40 beads and a bracelet requires 15 beads. So 40 for the necklace and 15 for the bracelet. And you can make that X and Y if you want. And we're going to write a linear inequality to figure this out. It doesn't really matter which is X and which is Y. So we're going to, let's just make this X and this Y. To graph this, you could do one of two things. You could find your X and Y intercept, or you could solve for Y. So I'm going to subtract 40x from both sides. So 15y equals, or is less than or equal to negative 40x plus 285. And then you would need to divide everything by 15. So 40 divided by 15, why don't we just, I guess, let's reduce it. So that would be negative 8/5 thirds plus 285 divided by 15 is 19. Alright, so what that means, negative 8/3, is 0 gives us 1/19. And then as slope, negative 8 over 3. As x goes up by 3, y goes down by 8. So let's go up by 3 and go down by 8. So 3 would give us 11. And if we go up by 3 again and go down by 8 again, 6 would give us 3. You could also plug points in and solve, if that works better for you. And then we're going to give two combinations and graph it. So the negative numbers aren't really going to make sense here. And my X again is necklace beads. And my Y is how many bracelets. And in the Y I need to get up to 19. And how about if we say Ada's jewelry? Okay, so 0 gives 19, 3 gives 11, and 6 gives 3. So this is going to be a solid line because it says at most, which means less than or equal to. And then we're going to shade below like so. So everything in the shaded region is a solution. This is probably a pretty important point if you want to add it in. So this would be our x-intercept. And to find x-intercept, you plug 0 in for y and solve. So if we do that, we would have, if we plug 0 in for y, we would have 40x is less than or equal to 285. So then you would just divide by 40. So 285 divided by 40 is 7.125. So if you want to add that number in, you can. And then these are different possible ordered pair solutions. 3 for the necklace, 3 necklaces, and 11 bracelets. 6 necklaces and 3 bracelets. 0 necklaces and 19 bracelets. And if you want to add that last one in, we could put 7.125 necklaces and 0 bracelets. Alright, and then the very last problem, we have a dotted line, and we're going to write our inequality this time. So the first thing that you have to do is figure out exactly 2 points where this crosses the grid perfectly. So it looks like there's a perfect cross right here and a perfect cross right here. Now, we could list the ordered pairs and find the slope that way, or we could just do rise over run. And this is 1 over 2, going backwards. Up 1, back 2. Up 1, back 2. So our slope is negative 1/2. And if you want to pick 2 ordered pairs instead, this is 0, 0, and this is 2, 1. And you remember how we found slope like this, 1 minus 0. This is 2, negative 1. I knew I lost a negative there. Negative 1 minus 0 over 2 minus 0 would be negative 1 over 2. So that's another way to find your slope. The b is the y-intercept. Well, the y-intercept is right there at 0. So our equation, if it was just a line, our equation would be y equals negative 1/2 x plus 0. But this is not a line. This is a dotted line, and it's shaded below. Shaded below means less than, and there's no equal to because it's a dotted line and not a solid line. All right, so that is the lowdown on graphing inequalities. Hoping that's making amazing sense. I'll see you tomorrow.